If you're able to follow along and understand what's going on here, that means you have a very strong concept of how addition and subtraction of rational expressions works. Okay, now if you're struggling with this, it means that we really need that your overall knowledge can be strengthened a little bit more. But it doesn't mean that you don't know how to do it. Undoing it is certainly a much tougher concept, but it really does test whether you have a strong concept of the processes of addition and subtraction of rational expressions. So I have shown you some steps here that you can kind of follow, and the more practice that you do, the better, the more sense you get of it. Okay, because we don't do this backwards. We're usually adding and subtracting instead of undoing the addition and subtraction. Okay, so this is a slightly different perspective to take on it, but again, if you can understand the perspective on it, both perspectives, you have an extremely strong sense of what we're doing here. Now, one of the reasons why I do show this is because this is something that they use in calculus. Okay, so this is not something you'd be tested on in grade 11, but something that is good mental exercise, but also something that does get used in calculus. Okay, so let's go ahead and do this again. So let's work out how we do this, undoing this addition. So first of all, I'm going to again factor first. So x plus 5, x minus 5. Okay. I want to then rewrite this in terms of the partial fractions with denominator plus 5 and a denominator minus 5. And we don't know what a and b is, so we need to set up some two relationships to work that out. The way we set up that relationship is we're going to rewrite this. We're actually going to just add it together. So we're going to multiply top and bottom by x minus 5 here, the top and bottom by x plus 5 over on b. And again, at this point, the denominator is not something we're going to focus on because we need to make sure that's equal to the numerator. So we need to show how this is equivalent to this. And we need to come up with two different relationships. So the first relationship again was looking at the x's. Okay, so we're going to do x, x, x. So we end up with ax plus bx equals negative x, or we can just say that a plus b equals negative 1. So there's our first relationship. Label that relationship number 1. The other relationship comes with the constant terms. Okay, so we end up with negative 5a plus 5b is equal to negative 15. So I'll simplify this to negative a plus b equals negative 3. And I will, okay, so that's relationship number 2. And what I'll do is I will subtract relationship number 2, or sorry, add relationship number 2, and that will get rid of one of my variables. Okay, so I end up with the a's cancel out. I end up with 2b equals negative 4. So b works out to be negative 2. Okay, so there's one solution. And then I can plug it back into the equation, either equation. So if b is equal to negative 2, a must be equal to positive 1. Okay, and there we go. So I've now decomposed my addition there. So it would have started off as x 1 over x plus 5 minus 2 over x minus 5. And there's my rational expression that was added together, decomposed into its partial fractions. These are what we call partial fractions. And again, we can test this by just multiplying. We end up with x minus 5 minus 2 times x plus 5 all over my common denominator. And when we do this, we can see that we end up with x minus 2x, which is negative x, negative 5 minus 5, which is negative 10. Oh, sorry, negative 5 minus negative 10, which is negative 15. And that's all over my common denominator of x plus 5, x minus 5. So I've undone, I can add this back together to get back to where I started from.